Imagine having a conversation with ChatGPT, but instead of getting vague responses based on outdated information, it could instantly access your personal documents, company knowledge base, or the latest research papers to give you precise answers. That's the power of RAG, and today I'll show you exactly how it works. Hey everyone, Alex here, and today we're diving deep into RAG, Retrieval-Augmented Generation, a game-changing approach to making large language models more accurate and useful. So what is RAG actually? At its core, RAG is a hybrid AI system that combines the powerful reasoning of large language models with the ability to retrieve specific facts from external knowledge sources. Think of it like this. Standard LLMs are like incredibly smart people who were locked in a room until 2022 with a huge library of books to memorize. They're brilliant in generating text and reasoning, but they're limited to what they learn during training. RAG breaks those limitations by giving model access to a custom knowledge base that can include your private data, the latest information or specialized content that wasn't in its training data. Just imagine, customer support chatbots can access your entire knowledge base, research assistant can analyze scientific papers, legal AI can search through case law and precedents. And that's just a few applications of RAG. So, how RAG actually differs from standard LLMs? Standard LLMs generate response solely on the patterns they learned during training. This creates three major issues. 1. They hallucinate facts when they don't know the answer. 2. Their knowledge becomes outdated the moment they're released. And 3. They can't access their private information or specialized data. RAG solves this problem by adding a retrieval step. Before generating a response, the system searches through a knowledge base for relevant information, then uses that specific data to inform its answer. Think of it as of combining your user prompt with search results, so it has more context to operate with. Here's how RAG works, broken down into its key components. Step 1. Indexing. We take our documents, whether that's PDFs, websites, databases, or any text, and break them into manageable chunks. Second step is embedding. We convert each chunk into a special type of numerical representation, called a vector embedding. It's like translating the text into something a computer can work with, for searching or comparing. Step 3. Storage. These embeddings are stored in a vector database, which is optimized for quickly finding semantically similar content. Now when user asks a question, RAG springs into action. So step 4 is query processing. The user's question is converted into the same type of vector embedding, so it can be compared with other vectors. Step 5. Retrieval. The system searches the vector database for the most relevant chunks based on semantic similarity. Step 6. Augmentation. The retrieved information is provided to the LLM as additional context, as I've said before. Step 7. Generation. The LLM generates a response using both its pre-trained knowledge and received information. What's really cool about this is that LLM now can reason over information it never saw during training, answering you precisely, grounded in your specific data. Let's look at the technologies that made each part of RAG possible. For embedding, we have models like OpenAI, Ada, Cohere, Embed, or open source options like BERT and Sentence Transformers. For vector databases, popular choices include Pinecone, VV8, Chroma, Quadrant, or even Postgres with pgvector if you're on a budget. For the retrieval, frameworks like LangChain and LlamaIndex have made building RAG systems much more accessible. And for the generation part, you can use OpenAI's GPT, Anthropic's Claude, or open source models like Llama, Mistral, or Gemma, or DeepSeek. And something you should probably know about is that RAG isn't perfect. So let's talk about some limitations. First, retrieval quality directly impacts output quality. If your system retrieves irrelevant information, your answers will be poor. Sadly. Second, there's significant computational overhead because now you're maintaining a vector database and performing similarity searches for every query. Third, context window limitations mean that you can only feed the LLM a certain amount of retrieved information. Now let's talk about reranking, a crucial improvement to basic RAG systems. Instead of taking top semantic matches from your vector database, reranking adds a second pass of evaluation. First, we cast a wide net to retrieve potential matches based on vector similarity. Then, a more sophisticated model re-evaluates each candidate to determine which ones are truly most relevant to this query. Tools like Cohererun can dramatically improve retrieval precision, often by 30 or even more % for complex tasks. Queries. Now let's take RAG to the next level. Agentic RAG doesn't just retrieve information, it actually decides what information it needs and how to get it. An agentic RAG system can decompose complex queries into sub-questions, dynamically decide which knowledge sources to query, even generate new search queries to fill knowledge gaps. Think of it as the difference between a librarian who just fetches books you're asking him for versus a librarian who suggests you additional resources and actually guides you through the entire research process. So how you can start building your own RAG system? The simplest approach is using Llama Index with OpenAI embeddings and vector store like Chroma. For production systems, consider Pinecone and Viviate for your vector database, due to their scalability and performance. To optimize retrieval quality, implement reranking with Cohere Rerank API. And if you're looking for cost efficiency, explore embedding models on Hugging Face and combine it with PG Vector in PostgreSQL. I'd love to know what specific use case you would implement RAG for. Will it be your personal knowledge base, customer support system, or something else entirely? Let me know in the comments, and if you found this breakdown valuable, please don't forget to like and subscribe for more practical AI content. Thanks for watching, and see you in the next one.